All right, this is lesson 5.5. Trapezoidal Rule is the name of the section. We're going to talk about the area of the trapezoid first. So, trapezoid is a figure with one set of parallel sides and one set of sides that is not parallel. We have a height. The height has to be perpendicular to the bases. We have our first base and our second base. To find the area of a trapezoid, you take 1/2 times the height, and then you take that times the quantity base 1 plus base 2. Or, the way I like to think of it is, you take the average of the bases. So you take the average of base 1 and base 2, so base 1 plus base 2 divided by 2. What's that going to, that's going to give you this distance, what's halfway between these two lengths. So it's going to give you this distance about right here. And you take that times the height. Reason being, what you can do is you could cut off this little triangle right here and put it right there. You can cut off this little triangle right here and put it right here. And then what shape would your trapezoid be now? It would be a rectangle. And then rectangle, you just take the width, which is half of base 1 times base 1 plus base 2 divided by 2. So it would be the average of our two bases, and then times the height, and you have your area. So that's just a different way to think of it. For me, that's easier to remember. If you just want to memorize this formula, that's fine. But for me, it just makes sense in my head, and I can picture it, to take the average of the two bases times the height. Now, trapezoids in calculus are going to be, at least in this lesson, are going to be drawn the other direction. Going to be drawn this direction. Your parallel sides are going to run vertically, like that. And so instead of actually calling them bases, we're going to call, like the first base, instead of b sub 1, we're going to call that y sub 0. It's going to be a y coordinate because it runs vertically. This is going to be y sub 1. Our height is going to run sideways, like that. So our area would be 1/2 times the height times y sub 0 plus y sub 1. So same formula, just different letters. Got the trapezoid turned sideways. Okay? Now trapezoids can be used to approximate the area between a curve and the x-axis. So let me give you that picture next. So you have a curve, something like this. Let's say this is x sub 0, x sub 1, x sub 2, etc. We'll go up to x sub 5, so x sub 3, x sub 4. I'm trying to make these the same width, same height, in other words, because the height's running sideways. And this is my x-axis coming this direction, y-axis coming this direction. I'm trying to approximate this area under here, between x sub 0 and x sub 5. And our x sub 0, our starting left boundary, we'll call that A. We'll call our right boundary B. Each distance between these is going to be our height. We're going to keep that height the same every time on this problem. Each of these is h, the height of the trapezoid. Again, the height runs sideways because our trapezoids turn sideways. What we're going to do is connect, because trapezoids don't have a curved side, they have straight sides. We're going to make a straight connect here. So the trapezoids won't fit perfectly into the curve, but they'll be close enough to get a good approximation. Right? So we're trying to get the shaded area. The shaded area, we know, is the integral from a to b of f of x dx. What we're trying to do is approximate that approximate that integral. And we want to approximate it using what's called the trapezoidal rule. So I'm going to put a squiggly equal sign to tell me that this won't be the exact answer, but it'll be close. It'll be approximately equal. What I'm going to do is take 1/2 of the height times, now if this is x sub 0, what do you think this first height would be called from here to here? Y sub 0. Yeah. And the second height, if this is x sub 1, what do you think this height would be right here? Y sub 1, right? So our first two heights are going to be y sub 0 plus y sub 1. So that formula would give you this area right here. Okay? Plus, now let's do the next on trapezoid. So it'll be 1/2 the height again, This time, our height on our left edge of this second, we're doing trapezoid 2 here. The height's going to be y sub 1 again. What do you think the height's going to be of this right side coming right here? If this is x sub 3, what would be the height? Or I'm sorry, x sub 2, I did the wrong one. Let me redo that. If that's x sub 2, what do you think the height would be called? Y sub 2. Some textbooks might call it f of x sub 2, but we're going to call it y sub 2. Etc. You might be starting to see a pattern now. The third, so now we've got this trapezoid area. Now I'm going to the third trapezoid. It's going to be 1/2 height times what two y coordinates do you think I'm going to use here? Y sub 2 and y sub 3. Yep, so we've got that one done. The fourth trapezoid's right there. It's going to be 1/2 height times y sub 3 plus y sub 4. That trapezoid's done. The fifth trapezoid be 1/2 the height times y sub 4 plus y sub 5. Okay? Now, looks like a huge long formula. Is there a better way to get the answer? And there is. I'm going to call it, I think I'm getting off my screen here. I'm going to come back so I get back on the camera again. So what we're doing is we're going to call it a trapezoidal approximation. First of all, what do all the terms have in common? 1/2 h. So I'm going to turn this so that someone watching it can actually see the whole formula there. There we go. So they all have 1/2 h. So we're going to factor out the 1/2 h out of each term. Out of here, 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 here. Then, how many y sub 0s do we have? Only one. We only used that height once, and that was on the left edge of the first trapezoid. How many y sub 1s are there? 2. Because that height got used on the first trapezoid and the second trapezoid. So plus 2 y sub 1s. And how many y sub 2s? 2 y sub 2s. Plus 2 y sub 3s. Plus 2 y sub 4s. How many y sub 5s did we use? 1. Only 1. So the trapezoidal rule is going to say that you're going to take 1/2 your height's going to be actually running sideways here, times your first y coordinate, which is y sub 0, and then double all those other y coordinates except for the first and last one. Your first y coordinate won't be doubled, your last y coordinate won't be doubled. And that's a quick way using that formula. You'll have to, it won't be on the test, you'll have to know it. You'll have to know that this is how you do the trapezoidal rule. You take 1/2 the height, throw all your y coordinates in there, but you only use the first one once, and you only use the last y coordinate once. Every other y coordinate gets used twice because it's bordering 2 trapezoids. That's a quick way to find an approximation using the trapezoidal rule. And it's on page 290 in your textbook. Why don't you go to that right now and look at that, page 290.